Hello and welcome to this course on Golang hacking. My name is Fahad Ali and I will be your instructor for this course. In this course we will learn about hacking. In the first section we will learn what is hacking. So we will learn about different types of hacking, for example how it is performed, and then we will also learn what are the different type of hackers, and we will also learn what are the ethical aspects of hacking. So is hacking even legal or not? So we will discuss these kind of things in our program. Then we will move on to the next stage of hacking, which is information gathering and reconnaissance. So in this section we will learn how to gather information. So there are a lot of ways in which you can gather information. So most of them, for example, there are two kinds, active and passive. In active gathering you basically actively scan the internet or the host or the victim machine, and then you try to find out if there is any vulnerability that you can exploit, or if there is a way that you can use or force the victim to communicate with you, and these type of things. This is basically a way to get an idea or overall information about how the victim machine look likes and what's its feature. For example, what's operating system it's running, if there is any port that is open that you can connect to, etc. These type of things. We will learn how to perform this network scanning. So we will learn different programs. For example, we will learn a program called Nmap or Network Mapper. This program will help us to gather information about the victim machine, etc. Then we will also learn about a network scanner. So we will build our own network scanner which will help us to gather information. This network scanner will help us, for example, in creating a program that will actively scan the devices in your own local network. In next section we will learn about MITM or man-in-the-middle attacks. These type of attacks are performed when the attacker puts himself between the victim machine and the internet, and in this way he can intercept or he can monitor all the traffic. So we will learn how to perform this man-in-the-middle attack. And we will learn how to perform ARP spoofing. ARP spoofing is basically a technique through which you can perform the man-in-the-middle attack. So here what you will do is that you will fool the devices or fool the victim machine into thinking that you are the router, and in this way you will get all his data packets or all his network communication that is originating from his PC to your own device, and then you will forward it to the internet and then receive the results back. So don't worry if it's too much at the moment. We will learn about this in detail when we enter into this section. And then once you are in between the victim machine and the internet, you can intercept all his traffic. You can read what the data packets he is sending or what the data packets he is receiving, etc. You can read and decrypt packets. So for example, if the user is logging on to his bank, etc., you can steal his sensitive information using this method. So for example, let's say if you are in a cafe and the victim machine is trying to connect or trying to use PayPal through his PC, for example, he will enter his username and password, and if you are listening to his network traffic, you can easily get access to his credentials. In next section we will build a backdoor. So what's a backdoor? A backdoor is simply a program that will give the attacker unlimited access to the victim machine, so you can get complete control of the victim machine through a command line interface. So we will learn how to build this program, and then we will have the complete control of the victim machine, and we will try to execute commands through a terminal or through command line. So we will build a backdoor from scratch. So what would be the features of this backdoor? So we will create a fully undetectable backdoor. So this backdoor will not be detected by any antivirus, since you are creating this backdoor yourself. So this backdoor won't be present in any antivirus database that is on the internet. So basically antivirus programs won't be able to detect, and they won't be able to distinguish if it's a real program or a backdoor. and you will get the complete control of the victim machine. And once you have this control, you can steal his sensitive information from his PC. So using this backdoor, you will be able to upload viruses onto the victim machine. For example, once you get the control, you can simply add registries or modify registries, and then you can add viruses or programs, malicious programs, and the antivirus won't be able to detect them. And then you can also steal his sensitive or personal files, etc. For example, if he has some folder or file that is sensitive, that contains sensitive information, let's say it contains his stored passwords, etc., you can easily copy these from his PC to your own PC. And then finally, we will learn how to build a Trojan. A Trojan is a program that looks legitimate on the front, but in the back end, it performs malicious actions. For example, let's say you have a simple program that is a calculator on front, so it shows calculations, etc. But in the back end is a backdoor, so it will try to connect with the server or with attacker machine, and then the attacker can get a complete control over this machine. And then we will build a keylogger. So a keylogger is basically a program that stores all your keystrokes into a file, for example. And for example, if you are successfully able to deploy a keylogger onto a victim machine, and the victim, for example, logs onto his bank, etc., or any website, for example, then if you have this keylogger running in the background, you can get access to all his keystrokes, so which simply means that you can steal all his passwords. We will learn how to build this program. So that's it. We will also discuss a few other things, but we will go into that as we move along. So what are the prerequisites for this course? So the first thing you need to know if you want to learn this course is Go programming language. If you have no idea about Golang, don't worry, I have a separate course on Golang that you can take, and I will link this course to their resources. So you must have an idea about how Golang works in order to learn this or in order to go through this course. And you must also have a solid background about networking. I will discuss networking in a small detail, but it is highly recommended that you have enough knowledge of networking to easily understand this course. If you don't have any networking background, this course will be really hard to follow. And also this goes without saying that you must have a PC with sufficient resources. So I would recommend at least 8 GB of RAM, because we will have to run different virtual machines which will require a lot of resources. It will work with 4 GB, but I recommend 8 as a minimum. Okay, so that's it for this. Welcome to this course, and let's start learning. Okay, so before we proceed further, there is a small announcement. So I will try to cover as much topics as possible in this course. And if you like this course, please rate this course and leave a review and give feedback. This will help me in improving my course quality. So thank you very much, and see you in next lecture. Alright, so welcome back. In this section, we are going to focus on computer networks. Okay, before we go into hacking, we first need to understand a few things about computer networks. So in this section, we will cover a few terminologies and things that we need to understand before we start the hacking process. So first thing we need to learn is called computer networks. So what are computer networks? So we will learn about what a network is and how it works. So what's the definition of a computer network? A computer network is nothing but simply a connection or a group of connected devices. So every device that is connected with each other forms a network. So it could be, there are different types of network. We will see later what kind of networks there are. But the basic idea behind networking is that every communicating device, or every device that is able to communicate data with each other, forms a network. A network could be either physical or wireless. For example, a Wi-Fi is a wireless network. Similarly, there are other networks. For example, if you have a LAN or Ethernet connection, this connection is usually called a physical or wired connection. And the core idea behind networks is that in networks, the devices are able to communicate or exchange data with each other. It could be a simple connection like a Bluetooth connection, even though this is not able to access the internet, but still it is able to communicate data with each other. So a Bluetooth connection is a kind of a network. So how do we understand network visually? So let's say you have a few devices. Let's say you have a mobile phone, a laptop, or a desktop PC, and they are all connected with each other. So even if they are not connected to internet and they are connected with each other through a router, this still forms a network, and this is called a local area network. Even if there is no internet connectivity between these two devices, they will still be able to transmit data from one device to another in the same network if they are connected to a same router. So I will explain what a router is, just bear with me. So the same idea is that if they are able to communicate, they form a network, and this is usually called a local area network or LAN in simple terms. And the next thing we need to learn is what's a node. A node is nothing but every communicating device inside a network. So nodes are defined by their addresses. So for example, if you have a if you have a mobile that is connected to your Wi-Fi, and similarly at the same time you have your laptop connected to the Wi-Fi, these two devices are called nodes and they will have unique addresses. I will explain what an address is next, but for the moment just understand that a node is just any connecting device inside your network. And now comes the concept of address. So we humans are identified by our names, but machines do not understand this language. So in order for machines to be able to communicate with each other, they need to know addresses in the form of numbers. So a node address is nothing but a simple 32-bit number. They are uniquely identifiable and they are numeric quantities, which means they are either numbers. They could be strings, which is a whole different topic. These addresses or these numbers helps machines to communicate with each other. So if the machine does not have a proper address, it won't be able to communicate properly. So when we are talking about addresses, we are usually referring to the IP address, which is a 32-bit number. So you may have seen this kind of numbers, for example 192.168.0.1, and this is called a private IP address. So using this, so if a router wants to communicate with your device in the same network, it will use your device's IP address, which would be this one. This is just an example. And then associated with addresses is another numeric identifier, which is called a port. So a port is basically a number that identifies a service running on the system. So every communicating device can have multiple services running. So for example, if you have a mobile phone, your mobile phone could communicate with, for example, YouTube. Let's say you have a mobile phone and it's running multiple applications. It is running WhatsApp, it's running browser, it's running some other applications in the background that is consuming or that is connecting or exchanging data with the internet. So how do your mobile phone or your router knows that which data is associated with which service or which application? So this is done through ports. So every port or every data that is coming from a specific port is associated with a specific service. For example, if every data or every internet data that is associated with your browser or with HTTP, which is a hypertext transfer protocol, will come through port number 80. And ports are usually a 16-bit numbers, so they range from 1 to 65,535. And one important thing to note about ports is that from port 1 to first 1K ports or 1024 ports are reserved, so you should not use them if you are developing a program. Use ports number that are higher than these numbers because they will interfere with the normal functioning of your PC. So as I already said, that different application or different services have different port numbers associated with them. So for example, Hyper HTTP or a simple text transfer protocol which was used earlier for web browsing is associated with port number 80. It's still used, but it's not very common nowadays. Most of the websites use this HTTPS protocol, which is a secure version of the same protocol. And then there is another protocol called FTP, which is used for file transfer. Okay, so now we are familiar with networks and nodes and addresses. So the next thing we need to learn is what's an internet. An internet is nothing but simply a group of or a global connection of group of networks. So every network that is connected worldwide forms a global network called internet. So a form of www or World Wide Web is a global network that is usually referred to the internet, but this is not the internet. This is just a part of internet, and the internet is a very broad network. Okay, so the last thing we will learn is called a gateway. So how do we communicate with the internet or devices that are not present inside your own network? So let's say this is your computer and you want to access a server. A server is nothing but a computer that is running 24/7 and that listens for incoming requests and then accordingly responds. So for example, when you access a website, google.com or facebook.com, you make a request to this computer or this server, and then this server will respond accordingly. Let's say you initiate a request from your computer to this PC or this server. So you cannot directly your computer cannot directly communicate with this server. Why? Because this causes a lot of problems in communication. So what they did was that they developed a concept called gateway router. So every local network has only one entry or exit point through this network. So as the name indicates, it's a gateway. So only through this gateway can your data go outside your network or come to your network. So let's say this is your local network and this is the server's network. And then if you want to communicate between these two networks, all your data must go through this router or this gateway device. So you will send a request to this one and it will go through this router, and if the server responds, the whole data will pass through this router and then come to your PC, and this device is called a gateway router. Okay, so MAC addresses are addresses that are used for communication inside your own network. So IP addresses are mostly used for communicating with devices that are not present in your local network, while MAC addresses are used for communicating inside, because inside your own network you can communicate with MAC addresses. And remember that when I said that even if you do not have internet connectivity, you can still communicate inside your own network. So this is because the inside communication is managed by MAC addresses. So even if there is no internet access, you can still use these MAC addresses to communicate with devices in your own network, and it stands for media access control. So MAC address is associated with each hardware interface. So in your laptop, if you have a Wi-Fi card, so the MAC address will be associated with your Wi-Fi card, and it is used in LAN only. MAC address is a 6-byte or 48-bit address, and it looks something like this. For example, D4 blah blah blah. So that's it. These are very basic terminologies, and in next lecture we will start using or building on top of it. So if you like this course, please rate it, and this will help me in improving my course quality. So thank you and see you in next lecture. Okay, welcome back everyone. In this section we are going to focus on hacking. So we will learn what is hacking and how it can be used, or how we perform hacking. So hacking is a process of getting unauthorized access of control. So you are not supposed to have the access to a certain computer or a certain server, and you somehow get a control over it through any mean. So this process is called hacking. So there are legitimate ways of getting control, and there are illegitimate ways. So hacking refers to those processes through which you bypass the user identification methods. For example, when you have to enter password or something like that, or you somehow exploit some vulnerability in the system, that you use this vulnerability to access the computer or enter the system. When we talk about hacking, we are usually referring to some malicious intentions. So we get a control over the system in order to perform tasks or activities that are malicious or that are not intended. So what are the different type of hackers? So the first type that we are going to study is called a black hat hacker. A black hat hacker is a one that performs the criminal activities. It is the hacker that we are mostly familiar with. For example, when we see movies and they refer to hackers, most of the time it's the one that performs criminal activities or performs actions that bypass the security of a system. And a true black hat hacker hides his identity. So a hacker never reveals his actual identity, because if he does, he's caught and he's performing malicious activities, then he's definitely going to jail. So he uses different methods, for example VPNs and using Tor networks, etc., to bypass or to hide his real identity. And a black hat hacker, the only difference between a black hat hacker and a white hat hacker that we will study next is of intentions. Black hat hacker has bad intentions, and his goal is to either destroy the system or somehow to use this system which he has control over for any evil purposes. And then there is the white hat hackers on the other end of the spectrum. So white hat hackers are mostly, they use their knowledge for good purposes. So their goal is to defend the systems from black hat hackers. They are mostly security researchers or penetration testers. They are usually hired by companies, and the companies paid them to audit their systems or test their security. So they are allowed or authorized to attack the systems. And then there are grey hat hackers who lie somewhere in between these two extremes. So grey hat hackers, they usually try to, for example, attack with machines, etc., and gain control. And if they get control, they will reveal to the owner or the person. So they are mostly looking for weaknesses in a system, and if they find some weaknesses and they, for example, they will try to maybe attack your system, and if they are successful or they somehow are able to do this, then they will tell you, or that they will tell the person that he has a certain vulnerability or security flaw in the system which can be improved. So their goal is usually not to destroy the system or to gain an unauthorized access. So they will reveal their secret at the end. So that's why they are called grey hat hackers. So hacking is not a single step. It consists of a lot of features, and it requires a lot of patience and knowledge. So if you want to successfully attack a company, then you have to perform a lot of steps, and it requires a lot of patience. So the first step that a hacker performs is called reconnaissance. In this step, the hacker tries to get maximum information about its victim. For example, if he wants to attack a company or an organization, he would first go, for example, Google everything, their emails, their websites, their phone numbers, their address, their people who are involved in their organization. So he will gather every type of information because the more information you have about an organization, the more easier it is for you to penetrate or to attack these organizations or people, whoever it is. And there are basically two type of reconnaissance, active or passive. In passive mode, you simply Google about, for example, let's say there is a company XYZ and you want to attack it. So what you will do is that you will go over Google and then you will search about this company and gather all the information. So this is called passive reconnaissance. Then there is another technique called active reconnaissance. In this technique, what you do is that you actually interact with people from the organization. You, for example, send them an email asking about something and things like that. And this is called active reconnaissance. So this is a little bit dangerous because you are practically interacting with the organization and it can be traced back to you. So the goal in reconnaissance is that you should keep your interaction at minimum. So don't go or don't interact with things you don't want to or you don't need to. So the next step is scanning. Once you have this basic information, you can build on top of it and get more advanced or technical information about their systems. For example, if you are attacking an organization, you would scan, for example, what are their email addresses or what are their domain names. And then you will also try to find out what their IP address of their servers are, or for example, if there is an open port on their server which you can use for communicating, etc. So this is more like a more in-depth or technical analysis. So you also search for operating systems or different services running on their systems. So if you get an idea about what operating system they are running and what services they are running, you can use these services to find out vulnerability about these services, and then you can attack these devices using these flaws. Okay, so the next step is called exploitation. This is the actual hacking process where you get the control of their device. So your goal is to somehow force them or somehow enter into their system, and once you have entered into their system, your goal would be to bypass the IDS or intrusion detection system. There are a lot of versions of intrusion detection systems. For example, firewalls, your antivirus. There are native security features that are part of intrusion detection system. So your goal is to bypass all of these. And then once you bypass all of these, then you exploit these machines for your own malicious intentions. For example, you get a control of a huge number of devices at the same time, and then you can use these devices to perform DDoS attacks or denial of service attacks. So denial of service attacks are attacks in which the person tries to take down a running server. Okay, so the next step is post-exploitation. So once you have entered or penetrated into their system, your next goal would be to maintain a long-term access. So you don't want to, for example, have just one-time connection and then you are unable to access it again. So the goal here is to modify registries, etc., so that you can access or control this device whenever you want. You will also try to get access to a higher privilege users. So by default, most of the users on any operating system are non-root. So there are certain actions that can only be performed by root users. For example, shutting off antivirus and these type of higher or risky tasks, they are mostly done by root users. So your goal would be to escalate or increase your access to the root level. And then your goal would be to cover your tracks. This is pretty common because you would not want to get exposed. So here your goal would be to delete logs and files that indicate your presence on the systems. And the last step is to implement this backdoor in a way that you get a long-term access by modifying system registries. This is related to the maintaining access that we already studied. Okay, so these are the steps that we can use for hacking purposes. But there are other techniques that can also be exploited or used for hacking purposes. So one technique is called social engineering. So in social engineering, you do not hack systems, but you hack people. And this is relatively easy if the person is not very tech savvy. So what social engineering basically does is that it employs or uses psychological manipulation. So you, for example, send a malicious link to someone working in an organization, and you ask them to open this link. And once he clicks this link, he in the background he downloads a malicious code that will execute on his machine, and then it will try to connect with your machine, and you will get an access to this machine. So this is one of the most easiest ways to perform hacking, but it also depends on the technical knowledge of the person. So as I already mentioned, that in this technique you trick people instead of systems, and it depends on the person. If the person is very tech savvy, it won't be easy to trick him into running or executing malicious code on his system. And social engineering exploits human trust. So if you send a malicious link to someone you trust, then it is highly likely that he will somehow click this link and you will get access, because humans are the weakest link in the security chain. So even if the systems are perfect, which is not possible, but still let's assume that even if the systems are perfect, then you can still fool or manipulate humans to get access to. For example, if someone gives you a password by mistake, or by you just ask him and he gives you, then the system, no matter how strong the password is, you can easily enter it if you know the password. And there is another relevant technique called phishing. So phishing is basically you send out a fake link which looks like a real link. For example, you direct him to a Facebook website which looks like Facebook, but you are actually running it. And whenever someone enters his credentials into the website, instead of going to the facebook.com, which is the original one, you will get all his credentials, and then you can simply use these credentials to log into his website. So this is basically obtaining sensitive information by fraud. So you will display, for example, fake login pages, etc., and things like that. So that's it for this lecture. So I hope you now have a basic knowledge about hacking. So in next lecture we'll start with practical hacking. Alright guys, so before we proceed further, we first need to install a few things which we will use in this course. So the first thing you need to install is whatever operating system you're using. So currently my host system is this Windows machine, and I will try to run virtual machines on top of it. So I will suggest you to do the same. Even if you're using Linux or Windows, whatever version you are using as a host machine, you have to install virtual machine on top of it, because we will use virtual machines, and I suggest you to follow the same procedure that I am doing in this course. The first thing you need to do is you need to install a virtualization software. So there are different options available. So one is called VMware, and the other one is called a VirtualBox. So they are both virtualization software. So I would recommend you to use VMware because I've used it and it's more stable and it performs better as compared to VirtualBox. And VMware Workstation also has a free version, so you don't have to pay anything for it. So go ahead and install it. So to install it, just open the browser on your host machine and download VMware. And here it has both pro version and free version.
It should be somewhere in products. So okay, so this one, workstation player, it's a free version and you can use it without paying anything. So just go ahead and install it. And then we will need some virtual machines. So we will use two virtual machines. One would be Windows 10, which would be our Windows machine. So we will use this Windows machine for our as a victim machine. And then we will have an attack machine, which is called a Kali machine. So there are different options available. There is one called Parrot OS, which is also a very good penetration testing operating system, but I would suggest you to use Kali because I am going to use Kali in this course. So in order to download a virtual machine, you can go to Kali website and download a virtual machine, and it will have everything installed, so you won't have to worry about installing it. Just go to VMware Kali Linux, and then it will tell you how to install it. I will link this in resources, but you don't have to install it. So just write download at the start, and here you can see that we are on Kali's official page. And if you go down here, you will see that we have an option for VMware and VirtualBox. So I'm going to use 64-bit VMware. So you can just download this image and everything would be set up automatically. You just have to open this image in your VirtualBox. And the other operating system is Windows. So you can download Windows ISO. So you have two options for installing Windows. Either you can use a pre-built VMware machine which is only valid for 90 days. So if you don't know how to install Windows, you can use this version and it will have everything installed properly. Or you can use a standard ISO and install this virtual machine on your operating system, and then you can open it. So we can search for VMware Windows 10 image, and here you can see that you can image. It's quite huge in size, so it's around 20 GB, and it will have validity for only 3 months or 90 days. So you can install this VMware version for it. So these are the tools that we will use. In next lecture we will proceed further, so I'm going to stop here. Alright guys, so welcome back. In this section we are going to install Golang on our virtual machine. So currently I have my Windows virtual machine open. So if you have followed the previous steps and you have installed this Windows and Kali, so go to this Windows machine and open a browser. So here just write download Golang, and it will put you to this link golang.org.tl, and then just install this Microsoft Windows version on it. It is going to take some time to download. Once it has downloaded, just click this link and open it, and it will pop up this installer. So click next, and by default it will save this to C/go. So leave it is unless you want to change, and click install, and it will install Golang on your system. Okay, so now it has installed properly. Just click finish to finish installing, and then in order to test if it's working properly or not, you may have to restart the system, but I think it should work. Just open up a terminal, just write go version, and it will tell you the version that is installed on your system. So if you see something like that, it means that Go has installed properly. So that's it for this lecture. I'm going to stop here and see you in next lecture. Okay, hello everyone. In this lecture we are going to learn about IDEs, Integrated Development Environment. So what are IDEs? IDEs are a tool that help us to write Go applications. You can even write Go applications in simple Notepad application,
but it's a very good idea to use proper IDs, which will help a lot you in programming and also in debugging a lot of errors. So there are a lot of IDs that people use, but the one I recommend are these two. The first one is called Visual Studio Code. It's a free IDE, so you don't have to pay anything for it. Studio Code, this one. Okay, so I'm using Linux. You can download this one. It's also available for Windows, so don't worry about it. You can just download it from here and install it. It's very easy to run. I'll show you its interface. So this is the ID, don't worry about it now. Okay, so this is the basic ID, this is the interface, this is where all your project files are located. Here is a small terminal that will help you in running the Go files, and this is the workspace where you will code. So to simply add a file, go to File, New File, and then name it and with the .go extension. So one thing to note here is that just go to the search extension part here and write Go. You will see I've already installed it, but you will see this extension, and just download this extension and it will help you a lot in writing your Go code. So this is a free ID and you don't have to pay nothing for it. So the other one is called Golang. It's from JetBrains. This is I think you have to buy this ID. It's I don't know how much is it, but it's a very good ID. I personally use the good for fast programming and development, and it also has the errors, but the only downside is that you have to buy the ID. So that's it for this one. Other than that, I don't think there is anything special. There are other IDs, but I don't use them and I don't have much idea about them. Yeah, most of the people use these two IDs. You can also, I think, use Notepad++, but it's very good idea to use either Visual Studio Code or Golang. Okay, that's it for this lecture. See you next one.
Alright, so welcome back everyone. In this section we are going to learn how to install Golang in our Kali machine. So our Kali machine will be our attack machine, so we also need to install Golang here. So in order to install it, first just go to this link, which is golang.org/doc and then \install, and you will be directed to this page, which is for installation. And here you can see that we have instructions for installing Golang on Linux machine. So the first thing you need to do is you need to install this archive. So just click on this link and download this file here. So I have already downloaded it. So let's just open it. Just open the download folders. And here you will see that we have this Golang file here. So the next thing we will do is we have to extract it. So in order to extract it, just go here and you can see we have a command here for extracting this Golang. So just copy this command and we are in this download folder. So open a terminal here. So just right click here and click open terminal here, and this will open a new terminal. So now in order to run this command you have to be a root user. So first write sudo and then paste this command here. So once you have pasted this command, just press enter and enter your password, which is Kali. So Kali, Kali, and press enter, and it will copy all this into this directory. Once you have copied it to this directory, just go to this file system and /user and then local, and here you have a folder named Go, which is the extracted one that we just extracted. You can see that it was extracted today. And now the next thing we need to do is we need to set up this export statement, which will tell the compiler or tell the system where to find our Golang. So in order to do this, we have to copy this command here and then go to etc folder. So it should be here in the file system. Just go to etc folder, so it should be here, and then there is a file name profile, so this one. So what you need to do is you need to open this file. So I'm just going to open it, and you have to paste this command at the end of the line, which is the one that I just copied. So I've already done it, but you have to do it, and you have to be a root user to modify this file. So you may have to open this file in a root mode, and then once you have copied it, just close it and save it. And then the next thing you need to do is open this Kali folder here, which is your home page or home folder, and press Control H, and this will show you all the hidden files. And then there is a file called .profile. So just right click it, and here you have to open this file in a root mode. And then once you have opened it, also paste the same file here as well. So this will tell the compiler where to find it. So once you have done these steps, the last step is just copy this command, which is source /home/profile, and just remove this dot at the end. So just copy it, open it, and once you are in this Kali folder, again press Ctrl H to hide these files, and open a terminal here and paste this command here simply. So this will tell the Kali machine to use this file for finding the Golang, and press enter. So now this will automatically set up everything. So the last thing you need to do is to check if our Go is installed properly or not. So to do this, just press Golang, and the next thing you need to do is write version. Sorry, it should be Go, not Golang. And you can see that we have a version which tells us which version of Golang are we using. So since we are using Go 1.14, so this means that our Golang has been installed properly for this user, which is the Kali user. So that's it for this lecture. So I'm going to stop here. Okay, so in this lecture we are going to learn a few things about Golang and how it works. So Go has certain environment variables that it uses for different purposes. For example, to find out where your project is located, or to find the Go libraries or Go standard libraries. So in order to find which Go environment variables are present, we can write Go in env or environment, and you will see that it will print out a lot of options. So this is a bit too much, so there are only a few environments that we are going to study or use. So the first environment that we are going to focus on is called Go path. So there it is. So Go path refers to the root path of your workspace. Workspace refers to the places that you will create your projects. So you can see that it is stored in home /Kali/Go. So if you go to the Kali home, you will see that there is no Go folder here. So your first step would be to create this Go folder here. So once you have created this Go folder, you have to create these 3 folders inside it. So this is a standard Go convention that is followed in Go community. So in Go workspace or Go path, we create 3 further folders, and one is called bin or binary, and this contains all your binaries for once you create these projects. So we will study what are binaries later. and then there is a folder called package, and this contains all the compiled binaries. So once you use some packages which are, for example, third-party packages or something like that, these will be stored in this. So don't worry if you don't understand everything. So if you are familiar with Go, you will be familiar with all these notations. And then there is a folder called source. So inside this source folder, we will create or we will code our projects inside this source folder. So go inside this source folder and create a new folder called Golang Hacking. In this folder, we will create all our projects from now on. So go ahead and create all these folders, and once you have done it, you will work in these. So the next thing is go root. So where is go root? Okay, so go root is the environment variable that tells the Kali machine to find where our Go is located. In our previous section, you learned that we copied our extracted archive into this directory, which is user_go. So if you have installed everything correctly, your Go root will work properly. If it's not, you have installed Go somewhere else, you have to modify this Go root variable to point to where you extracted this Golang archive. Okay, and then there is other variables, for example go exe and some other. So we will study these variables later, but for the moment we just need to focus on these two variables, go path and go root. Okay, that's it. So I'm going to stop here. Alright, so welcome back everyone. So now we have everything set up, so let's get into coding. The first thing we will learn is how to execute commands on the system. So if you are a hacker, you will often need to execute commands on the system, whether it is your own system or victim machine. So what you would want to do is to execute commands. Go has a certain package that enables you to execute system commands. So before we go into creating our code, let's first set up our directory structure that will help us as we move along. So in order to set it, first I am currently in my home directory. So what you would want to do is go to this Go folder, and then inside this Go folder, go to this source where we will code everything, and here create a new folder called Golang Hacking. So we will develop all our projects inside this folder. Once you have built this, the next step you would want to do is just open this and create a new folder called execute commands. So this is the first module that we will cover, in which we will learn how to execute system commands. So what are system commands? System commands are basically nothing but whatever we write in our, let's just go to home. So whatever we write in our terminal, this is a command and it has an associated output. So let's say we want to check which files are present in our directory. So we will write the list command ls, and you can see that it lists out all the directories and files that are present in this current directory. So our goal is to create something like that, a program that will run commands according to our wishes. So in order to create it, we will develop this program at the moment just for Linux, but the procedure will be exactly the same for Windows as well, except for few minor changes which we will look into later. Okay, so the first thing we need is a module or a package that will help us to execute commands. So Go has a very important module called OS, which has a sub package called execute, and this package helps us to execute system commands. So the first step we would want to do is to import it. So we can say import, and then we can give the name of the package. So the name of the package would be OS. So it's a part of OS. So whenever you write OS, if you are using Golang, you will see that you will see suggestions for different sub packages. So currently I am interested in this package, which is OS/execute. So I'm going to double click it. So now you can see that it says an error because it is not used at the moment. So now I will go here, and first we will define which command we want to use. So let's say we want to find out Actually, let's just try the ls command, which will list out the directory or files in our current directory. So we can name this variable as the command to execute, or just command is fine. And then we will set it to list. And then we will use this package to execute it. So in order to execute it, we can simply call this package execute, and you can see that it has several methods. So the method we are interested in is called command, and it requires the strings and arguments of that string. So I can write, or I can use this function, and then you can see that it requires the actual command. So we can put the command here, and then if you go to the documentation, you will see that command returns the command struct to execute the command and the named program with given arguments. So basically what this function does is that it executes command and returns an object, which is not the output but a command, a special type in Golang. So I'm going to call this as command object. And now at the moment we have an object, but what we are interested in is the standard output. So what this command outputs. So in order to access the output, what we can do is we can either save it in a variable, or we can display it on the screen. So what I would like to do in this section is to display the output on screen. So what we have to do is we have to set the command object output. So you can use this command object, and if you want to access its methods and fields, you can simply press dot, and now you can see you have different options. So you can see we have an option called standard error and standard output. So at the moment we are interested in output of this command, so we can write std out, and the next thing we will like to do is we would want to set this output to our standard output, which is the output of this terminal. So we will like the output to be displayed on this terminal. So we can set it to os.stdout. So it will take in the output from this command and it will print it on the screen because we are setting it to the output value. And then similarly we can do the same for error. So if we receive an error, we can do the same process as well. So we can say command object.std error is equal to os.std error. Now that you can see that I just wrote os.std out, and Golang automatically imported this OS module. So this may not be the same for your IDE if you are using a different IDE. So you may have to import this OS manually. Now we have set all the parameters of this command object that are relevant to us. The next step we would want to do is to simply call a method called run, which will actually run this command. So we can say command object.run, and this would return this command. And if there is an error in running this command, it will return an error object. So if you go to the documentation, you can see that run starts a specific commands and waits for it to complete. And if you check here, you can see that command.run returns an error. We can simply check for the error. So if error is not equal to nil, we can simply print out this error. So we can say log.fatal and then error. So I'm using log.fatal because this will exit the program if there is an error in running this program. So now we have our program complete. So let's just run it. So in order to run this file, which is main.go, I have to use a certain command, which is go run main.go. So if I press enter, you will see that let's just clear the screen and try again. And now you can see that we have an output called main.go. So in this directory, which is p1_execute_commands, we only have one file, which is main.go. So it lists only one file here. So let's say we change the command and set the command to the present date. Let's say we want to check the date. So currently if I write it in my terminal, you will see that I get the date. But if I run this file, so go run main.go, and now you can see we get the same output. So we can see that our program is working perfectly. We can also check if it can handle error properly as well. So let's say we misspell it. Instead of date, we write date 3, and we run main.go, and now you can see that it says date 3 executable file not found in path. So this is handling the error because the shell or bash is thinking that this date 3 is a file instead of an actual command. So let's go back to it and run it again, and you can see that it runs perfectly. So now you know how to run or execute commands on a system. This will help us in creating our programs, for example creating our ARP spoof program, which we will develop later, and also when we build a reverse shell in which we will run commands on Windows machine from our own PC. So this is the basic of executing commands. So I'm going to stop here. In next lecture we will proceed further. Alright, so welcome back everyone. So in our previous lecture we saw how to run commands on a system. In this lecture we are going to refactor our code to make it look more clean and nice. So we will create a function that will take in the command, and then it will return out or print out the results. So I'm going to create a new function here. So let's call this function execute command. And in our previous case we saw that our function was only able to take one input, so which is the date, and if we want to give multiple command line arguments, we were not able to provide these arguments to this function. So here we are going to develop a functionality so that we can handle command line arguments as well. So the first argument this function will receive would be the command or the actual command, for example date or ls, as we saw in previous lectures, and this would be of type string. And then we would like to provide any number of arguments in a string list or string array. So we can create an array called argument array, and it would be of type string list. And then this function is going to return an error. So the first thing we will want to do is we would set this argument array to a new variable called arguments or args, and then we will call this function which is execute.command. So I'm just going to copy everything from here, so just cut it and paste it here. And then what we would like to do is to provide this argument inside this function, because if you check documentation you can see that it can take any number of arguments. So we can provide the same variable or this variable here. So I'm going to call this as args, and then we will write 3 dots, so we imply that we are taking any number of arguments. Since we are already returning this error from here, so we don't have to initialize it here again, so we can remove this column from here. And then if there is an error we can simply print so we can say return. Otherwise, if everything works perfectly, we can simply return nil from here. So now we have a function that takes in any command line argument and then returns out or prints out the results on the screen. And here what we can do is we can call this function. So we can say execute command, and then we will provide the command. And then let's say if we want to provide another argument, let's say we want to run this command which is ls -l, which would list in detail. So we would like list here, and then we would provide the arguments in the string format. So we can say string, and the second argument would be -l. So if we run this code now, we can say go run main.go, and now you can see that it lists out all the details about this file. For example, when this file was created, which operating system is it, what's the permission, and also the number of bytes, etc. So that's how you can refactor your code. So this is an example, and you can follow this example in next lectures to refactor your code accordingly. So I'm going to stop here, and in next lecture we'll proceed further. Alright, so welcome back everyone. In this section we are going to focus on changing the MAC address of our interface that we are using. So in this case our interface would be our Wi-Fi card or this network adapter. So you can see that we have a bridge network adapter. So why do we need to change our MAC addresses? So in this course we will develop some programs, for example ARP spoof, which will help us to become a man in the middle. So to perform these attacks you expose your MAC address to the victim machine. So you don't want to do that. So what you will do is that you will try to change your MAC address for the moment, and once your attack is completed you can go back to your normal MAC address. So masking your MAC address will provide you safety or security. It will help you in hiding your identity. So before we go into creating a program for changing our MAC address, we will interact with ifconfig command in our Kali machine. This command helps you to configure IP addresses or net related activities in your Kali machine. So the first command we are going to use is called ifconfig. So before we go into details of ifconfig, first let's see what the private and public IP address is. So a private IP address is the one that is used inside your own local network, and this IP address is not accessible outside your local network. So this address is something like this, for example 192.168.0. and then there would be some number. So these last two things could change. For example, it could be 15 or something, but this will mostly remain the same in case of our local networks. This could also change. It could be 172 for example, but most of the time it will be something like this, 192.168.0.15. So if you don't see anything like this, what you can do is go to this network adapter settings. You can go from here, and once you have this network adapter settings, click on this bridged condition and tick or check this box, and this will change your IP address to this format. So now your IP address will resemble like mine. So the next thing is a public IP address. So this is an IP address that is provided to you by your internet service provider or ISP, and this is usually static and you cannot mostly change it unless you are using VPNs. A public IP is used whenever you are interacting with something that is outside your own network. And if you are interacting with something or some device that is inside your own local network, then you use the MAC address. MAC stands for Media Access Control, and it is used for all the local communication that is happening inside your own network. So, and similarly, IP addresses are used for communication outside your own network. So there are ways to hide your identity. For example, you can hide your IP address by using VPNs. VPNs are virtual private networks, or programs or softwares that help you mask your identity. You can buy them, and even you can use some free versions, but most of the time you have to buy this software. And then in order to change a MAC address, so since MAC address works inside your own local network, so you don't need to pay anything for changing your MAC address, and you can do it locally on your own machine. And it helps you to hide your local activity. So if you are performing some attack in your local network, it helps you to mask your identity because you can hide your real MAC address. So in this section we will build this MAC address. So before we go into building it, let's first check out the ifconfig command. So ifconfig is used for finding out your IP addresses or IP addresses for your local interfaces. So I am currently on Kali 2020 version. So this Kali user is not a root user. So previously in earlier versions of Kali, you could simply write ifconfig and this would work. But in Kali 2020, this does not work. So you have to use sudo before it in order for this command to run properly. So you can simply write sudo ifconfig and press enter, and then it will ask you for password. Just provide the password, which is Kali, and now you can see that it prints out the IP addresses for different interfaces. So don't worry about this interface, just focus on this ETH0. If you are using Windows, it would be different. It would be something like WOLP, etc. But since we are working with Linux, it is ETH0, and I think the same command works in Mac OS as well. So instead of ETH0, it would be EN0, I think. Okay, so now you can see that we have, this is our private or local IP address. So it is 192.168.0.23. And then this is your IPv6. So we will not focus on IPv6 in this course, so we will only focus on these two parameters. So one would be this IPv4 address, and the other one would be this one, which is the MAC address for this interface. This interface is nothing but a physical hardware device that provides you network connectivity. In next lecture, we will build a program using ifconfig, and then we will try to change this field, which is the ether field. So I'm going to stop here. Hello and welcome back everyone. So in this section, we are going to learn how to change the MAC address. So in order to change our MAC address, we have to follow a certain sequence of commands. The commands are these ones. So the first thing you need to do is you need to shut down the interface in order to change its MAC address. So to shut down its interface, you can simply write ifconfig and then ETH0 and then simply the down command. And this will turn off or shut down the interface for which we want to change our MAC address. The next thing we want to do is we want to know what fields we want to change. So since we want to change the MAC address, which is represented by the ether field, so if you open a terminal and write sudo ifconfig and write the password, and you will see that the MAC address is represented by the ether field. So we will write ifconfig and then the ETH0, which is the name of the interface, and then since our MAC address is a hardware address, we write HW and then the field that we want to change, which is ether. And the last argument is simply the new MAC address that you want to assign to your own laptop or your own interface. And once this command runs successfully, the last thing you will do is you will restart or turn on your interface again, which is done by using ifconfig, ETH0 and up. So by running these three commands, you can change the interface, and here you can note that this is a variable. The rest of this command remains the same. So the only variable here is this MAC address that you want to change. So in next lecture, we will build a program that will change our MAC address. Welcome back everyone. In this section, we are going to build a program that will execute all these commands. So in order to use this program, what we can simply do is we have already created a function that executes commands and gives back the results. So what we can do is we can just copy this function and paste it here. So I've done nothing else. I've just copied this function and pasted it here. So now since these commands require root privilege, so we have to provide password. So we need some way to interact with the command line. In order to do this, where we have declared the standard output and errors, we can also declare standard input here. So we can say standard input is equal to os.standard input, and then we can simply use or run these commands by calling this function. So we can say execute command, and now the first command should be sudo. because we want to run these commands as a root user, so we have to provide sudo as the first argument, and then the last or the next arguments would be the arguments for these commands. So we can simply declare a new variable here, a string array, and the first one would be ifconfig eth down. So we can write ifconfig eth0 and then down, and then similarly we can write these as well. So I'm just going to duplicate it by pressing Ctrl D, and here I can change it, so this should be HW, and the next argument should be ether, and the last argument should be the new MAC address. So I'm just going to copy this one and paste it here. Alright, so and at the end we have to re-enable this interface, so we can write eth0 and up. So now we have completely implemented this program which will take down the interface, shut down the interface, and then it will change the hardware or MAC values, and at the end it will restart the system. So we can simply run this command. So we can say go run p2, and since I've already done it, so I've already provided the password here, so I ran this program once before. So but for you this will ask for password, so provide the password here and it will execute this program. And once it has executed, you can simply write sudo ifconfig and provide the password, and now you can see that the ether field has changed. So previously it was something else, but now it is this new value, which is the value that we just declared. So in this way you can mask this MAC address of the device. So let's stop here, and in next lecture we'll proceed further. Alright, so welcome back. In our previous programs we wrote these values inside the program, so the value for eth0 and this value which is the new MAC. So these two could be variables in our case. So let's say you have an other interface which is not named eth0 and you want to change the MAC address for this interface, then what do you do? So we want to make this program in a way that it is reliable and it can work with any interface and it can set the any value that we want. So we will use flags to build a command line application, and now this command line application will help us to change these values or set these values. So the first thing we will require is the flag module. So we will create a new variable called interface, and then we will use the flag module. So we can say flag.string, and now what I want to do is I want to provide these eth0 and the new MAC as a command line argument. So you can see that if you check the documentation, and you can see that it has three values: name, which is string, value, which is string, and then usage, how do you want to use it. It's also a string, and it returns a string pointer. So let's define first what is our name. So we want to name our interface as iFace. So this will be the value of variable we will provide in the command line. And then the value, so let's say we set the default value to eth0, so that if we don't provide any interface, it will take eth0 as a default value for interface. And then we will provide the usage or the help message. So we can say that this would be the interface for which you want change the MAC. So now we have one variable called interface. So now we will want to create another for this MAC address. So I'm just going to copy and paste this new line, and here now let's call this as the new MAC. So the variable name would be the new MAC, and its value, let's say we don't provide any default value for this one, and then its usage would be the provide the new MAC address. And then since this function returns a pointer, so actually before going forward, let's change this interface into new MAC, And the last thing we will do is we will parse these flags. So we can say flags.parse, and it will automatically parse these values and store these values in these two variables. Now we have to use these variables here. So instead of eth0, we can say that pointer to interface, because remember this returns a pointer, so we want to use its value, so we use a dereference operator, which is star. And similarly we will call the interface here and interface here, and also we will change this value to new Mac. So now if we want to run this program, we can simply say go run p2 change Mac, and let's see what happens if we don't provide any interface. You can see that since we did not provide the new Mac address, it says that cannot assign requested address, because we did not provide any interface value here. Okay, so let's just for testing purposes, let's remove the default value as well for this interface, and let's see what happens. And you can see that it prints out an error called error while getting interface flags, so no such device. Now you can see that it does not it knows that we did not provide any interface. So let's just run this again, and now we will provide the values. So the first variable is called interface, so we can say iface equals to, and then we will write eth0. So this dash interface means that we are providing the value for this variable, which is this one. And then similarly we can write new Mac equals to 0011223344, and now instead of 55, let's say we want 66. Okay, so let's press enter, and now you can see that the command ran successfully. So now if I go to the terminal and write sudo ifconfig and provide the password, now you can see that the value of ether is 0011223344, and then at the end it is 66, which means that this command ran perfectly. So in this way you can provide the command line arguments. So one further thing we can do is note that this is currently a Go file. So if I list it, you can see we have two Go files, p1 running command and then p2 change. So we are interested in this one. So what I will do here is that I will try to build an executable. So we will build an executable for Linux machine, and this executable will contain everything bundled together. So even let's say if there is no compiler on your Kali machine for Go, you will still be able to run this executable because it will have all the dependencies included. So in order to create an executable, we can simply call go build, and then we will provide the file name. So let's check it and let's list this again, and now you can see we have a new file called p2 change Mac, and now this is an executable. So let's clear it, and if I list -l, you can see that this last tag is X, which means that it is an executable. So in order to run this executable, we can write ./p2, and you can see that if you press tab, it automatically selects this one. And note that there is no .go extension at the end. And we have to provide the same commands here, so let's just copy it from here and paste it here. So now instead of 66, I will write 88, and you can see that it ran successfully. Now if I run this command here again, you can see that our updated MAC address is 0011223344 and then 88. So this means that our executable is running successfully. And now even if we ship this executable to some other machine which does not have Go installed, this will still work because it contains all the binaries included inside it. Okay, so this is how you can create an executable and also parse the command line flags. So I'm going to stop here. In next lecture we'll proceed further. Okay, so in this lecture we are going to develop a TCP scanner. So what this scanner will do is it will try to connect with an IP address that we will provide, and then it will return back a connection acknowledgement which will tell us that the connection has been established properly. So TCP scanners are used for active scanning. For example, if you are in a network and you want to scan an IP address, then you can ping this IP address and get back different results. You can use this to, for example, know if there is any port open which is port open on the PC, and then you can use this port to attack this victim machine. So TCP scanning is very important step in hacking these systems. So what in this lecture what we are going to do is we are going to scan an Nmap, and then we are going to get back the results, and then we will try port scanning. So let's proceed. So the first thing we need to do is we need to dial the TCP scanner or the IP address that we want to use. So the first thing we need to do is we need to define an IP. So in this lecture we are going to scan this address, which is scanme.nmap.org. So this is an an address provided by Nmap, which is the organization that has developed the program called Nmap or Network Mapper. So what this IP address represents is that if you ping it, it will return back an acknowledgement that you have been able to scan it or connect with this IP address. As we will move forward, you will see what we are trying to achieve. So the next thing you need to define is you need to define which port you want to use to communicate with this IP address. So in this we are going to use number port 80. So once you have that, the next thing you need to do is you need to connect with this address. To connect it, Go has a package called net, and it has a method called dial, which can be used to communicate with different IP addresses. So I'm going to use net.dial, and then you need to provide certain things. The first thing you need to do is you need to define which network layer protocol you want to use. You can use different network protocols. For example, you can use TCP, UDP, and several other. But in this lecture we are focusing on TCP. TCP uses a network of acknowledgement. For example, you try to connect with another machine, and then another machine sends an acknowledgement back which represents that the connection has been established properly. You can read about it online, but the most important factor is that it uses signals for communication and acknowledgement. So we are going to use a TCP connection. So the next thing you need is an address. So you have an IP address and a port, and then you can use address. So in our case, address would be IP and port, but you have to represent it in a different format. So an address could be something like this. For example, IP plus, and then you have to provide a colon which tells this net.dial function that the IP address has completed up to this point, and then after colon you define which port you want to use, and then I'm going to put this address here. So now what this function will do is it will try to dial this IP address. If you press documentation, you can see that dial connects to the address on the named network. So this is our network, and it will try to connect with it, and it will, if there is a successful connection, it will return two things: connection or an error if there is no connection. So then we can say that if error equals to nil, which means that the connection has been established properly, we can simply print out a statement. Print ln. We can say that connection established, and then we can tell which IP address it remote address dot string. So this will tell us which is the server which is responding. So we are sending the address in a letter format, for example scanme.nmap.org, and this is not in the digit form, for example something like 334.56.7.3. If you know the IP addresses, you will know that IP addresses can be represented in two forms, either using numbers or using these letters. So a DNS server will resolve this address into this thing which is numbers. So our program is complete now. Next we will run this program. So I'm going to use go run p1scan. As you can see that it says connection established, and then it returns this IP address which is 45.33.32.156. So this is the IP address of this address. In this way we can ping this. Here we can replace IP with anything that we want to scan, and then we will be able to scan it. Okay, so now we have a program that we can use to scan or ping the address that we already defined here. The next thing we want to do is we want to scan a number of ports. So our current program just scans port number 80, which is here. But what we want to do is we want to scan a number of ports. So to do this, what we can do is that we can iterate over from 1 to 100, and then each time we change the number of port, for example which port we are using. So let's create a for loop here, and then we define a variable called I, which would have a value of 1 initially, and then we will increment this value over each iteration. And then let's say we want to scan 100 ports, and the post condition would be that we will iterate or increment, and then we will put this whole thing inside the loop. Now if you write just I here, you can see that there will be an error, because this thing which is I is an integer, but this whole thing is a string, so you cannot concatenate an integer onto a string. So there are various ways you can work around it. Either you can use this thing to convert it into an integer. Let's remove this port here and work with it, and if I run it, you will see that it works perfectly, but there was a slight problem that I will explain later. The next thing we want to do is we can use the sprintf function. So what you can do is you can use fmt.sprintf. So what this function will do is, if you go to the documentation, it says that sprintf formats according to a format specifier and returns the resulting string. So what we want to do is we want to define a format here. So our first thing should be IP, and then we need to provide this dot operator, and the last thing we will define is a %d operator. So this %d will replace I, and then it will return the whole string into this address. So this I will be replaced here, and this whole thing will become a string and return to this address variable. And then if there is a connection match, what we can do is we can say connection established, and then we can define the port number, which would be, let's call it printf instead of println, and then we can say port %v, which would be the value of this port, and then we can give out I, because this is the port number that we are working with. So if there is a connection from some port, it will print out its value here. So if I run this again, you will see that we got a connection from port number 22.
So there is some issue here. So this is a formatting issue. You can see that we got connection from two ports, so port number 22 and port number 80. So these two ports are open and we got a connection from these ports. In next lecture we'll try to build a concurrent program that will do this process in a more faster way. Okay, so there is this thing port 22, and then there is an error which is extra string, and I will try to remove this in the next lecture. Okay, so since it's a format specifier, so %v belongs to I, then we need to define another variable here which would be %s, or let's say %v. Oops. Since it's a string, %v or %s both will work. So what it will do is that it will put the value of connection result here. So if I run this again, let's put a new line character here so it's easy to understand, and run it. You will we will get a connection from two ports, so port number 22, and then we will get a connection from port number 80. So these two ports are opened in this address, and then you can communicate with these ports. As you can see that the program has finished executing and it has found out that there are two ports open, 22 and port number 80. Okay, so now we have a scanner that scans 100 ports, but the problem with this scanner is that this scanner is very slow, and we know that Go has a very important feature called concurrency. So what we are going to do in this lecture is to use concurrency to build a more faster scanner. So what we are going to do is we are essentially going to use or put all of this functionality in a Go routine, and then we will call this Go routine. But before we do that, we have to make sure that all the Go routines are run properly before the main function is finished execution. Because if the main function finishes before these Go routines are run properly, what will happen is that we won't see any results here, and the Go routines will run in the background and return the results, but the main function will have already finished executing, so you won't see anything. So let's create a function called function, and this function will be, let's say, called scan port or something like that, and this will take the port number, which would be port, and it would be of type integer, and then this function is going to perform this functionality. So I'm going to copy this functionality here, I'm going to cut it, and then I'm going to put it here. So we can hard code the IP address here, so we don't have to give IP address every time, but you can modify the function. And the next thing we need to do is, instead of I, we need to define port. It should be port here, and then at the end we should close the connection properly, so connection dot close, so the connection is not left hanging. Now we have put all our functionality that we defined here into this function, and then we can simply say go scan port, scan port, and then we can simply give the port number here, and it will run the program in concurrency. But there is a problem with this program, because if we run it like this, what it will do is that it will go to 100 iterations and it will exit, and before we can check that if there is any port open, our main program will have finished. So what we need to do is we need to introduce a wait function. So Go has a very efficient feature called wait group. So what we can do is that we can add wait groups to the queue and then wait for them to finish. Once everything has finished, it's like a counter, so you add something to a counter and then wait for it to finish. Once it has finished, and once the counter comes back to 0, the main execution stops. So what we can do is we can define a variable here. I'm going to call this variable as
WG, it represents weight group, and then Go has an internal package called sync.weight group. So the type of the variable is sync.weight group, so it contains a weight group that will help us in keeping a track of how many Go routines we have started. The next thing we need to do is we need to add elements to this weight group. So weight group dot add function will add 1 each time this loop is iterated. So whenever a Go routine has started, it will go into this, it will start adding a counter, and then once the Go routine has finished, we'll exit this counter. But if you go to this function, you have to see that the scan port. So once this Go routine has finished properly, what we want to do is we want to finish or reduce this counter here. In order to do this, we have to pass this object into this function as well. So what I'm going to do is I'm going to pass a pointer to this weight group. So it should be something like this, sync dot weight group. So now this function has a pointer, and then it can use this weight group variable inside this function. So once it has finished completing, we can do it. We can add a defer statement here, wg.done. So what this function is, when this function goes out of scope, it will reduce this counter again. So here we are adding this counter, wg.add, and then once the Go routine has finished, we can decrease this counter. Unless this counter goes to 0, this function will block, this main function will be in a blocked mode. And then I'm going to pass wg here. I have to pass the reference to this weight group, not element itself. So now almost our functionality is completed. The last thing we need to do is we need to add a wait function here, wg.wait. So this function will check if this counter has returned to 0 or not. So here we are incrementing counter. When the Go routine finishes, we are decrementing counter. So this works for all the 100 iterations. So when the iterations are, unless this wait wg.wait determines that this counter has returned to 0, it will be in a blocking mode and it won't close this main function. So it will wait here. So if I run it again, there is some problem here, invalid memory address. So our previous program has a small error because when we try to connect with it, so for example, if the port number 1 is not open, this connection.object will be empty. But what here we are doing is we are trying to close this connection which is already empty. So this is raising an error. So we have to modify our logic. So what we are going to do is we are saying if error is not equal to nil, we can simply return this function. So we don't want to proceed further. But if there is an error, if the error is nil, we can proceed further and close this connection properly. So let's run this again, and you can see that clear. You can see that we don't see any output. This is because we didn't put a print statement here. So I am going to say %d is open. So backslash n. So what we are trying to do is port. We are going to print out if any port is open. If it's not open, we are simply going to return. So I'm going to run it again, and now it says 2 ports are open, which are 80 and 22, and now you can see that execution is quite fast as compared to our previous program when it waited for a very long time to show the results. You can now see that it gives out results in just 1 or 2 seconds. Nmap is, and you can learn everything about Nmap here,
But in this lecture I'm going to show you small operations how you can use Nmap for information gathering or other purposes. So let's start working with Nmap. In Kali Linux it's I think enabled by default, but if it's not, you can install it by using sudo apt-get install Nmap. But I already have installed it, so I don't need to install it again. So let's start with basic operations. So Nmap can be used to ping or check if a host is or device is up or not. You just have to give the IP address of this device and you can see if it's working or not. For example, if we want to check if my Google server is working or not, for example the Google server that I using to access information through Google is up or not. So to do this, it's also a ping operation. So we can simply type nmap and then space and then the name of the host that we want to test. In this case I want to check out my Google server, so I'm going to write www.google.com. So as you can see that Nmap has started. It takes some time to scan it, but now the scan is complete. As you can see, it will give us the IP address of the Google server and also the DNS server, reverse DNS record, which is here. So this is how you can access or gather information about the host. For example, if you want to attack certain website, then you can use this to get the IP address of the website or server which is hosting this website. So this is how you can gather information about the host. So this is information gathering over network, which is given by this website, a link. You can also access it directly through the IP addresses. For example, if you want to know you want to ping your Google DNS server, so you can simply write nmap then 8.8.8.8. so this is the IP address of Google DNS servers. So let's wait for the execution to happen. As you can see that it gives us that the host is or our DNS server is up, and it scans different ports. I think it scans 1000 ports by default, and then 998 of these ports are unfiltered or behind firewall, and these two ports which are open HTTPS, which is used for communication, and then remaining resolving, I think is port 53. This is used for DNS servers. So these two ports are open and you can communicate with the server using these ports. Okay, so this is how you can access hosts that are represented by their IP addresses. Now if you want to scan a host in your local network or want to check if there is a host which is available on your network or not, then you can use nmap nmap 192.168. this is my local network. So if I want to ping router, I can use 192.168.0.1, which is the gateway. As you can see that now the result has returned quite quickly because it is in my own local network, and you can see that it has 998 ports which are closed, and then it has 2 ports which are open. So this is how you can ping a host on your local network. Okay, you can also search a range of hosts. For example, nmap 192.168.0.1 until, let's say you want to test first 30 hosts, that you can define a range, for example 1 till 30, and it will scan all the networks that are active or running in between this range. So it will scan 30 networks, 30 hosts, and then it will return the results which hosts are up and running. So let's start this and wait for it to complete. Okay, now the scan is completed. As you can see that there are certain hosts that are running. So I'm scanning from 1 till 30, and this is my gateway router, which is located at 0.1, which is up, and then I have a host which is a Linux machine, which is, sorry, it's not a Linux machine, it's my phone, which is at 192.168.0.10. Similarly, then I have another Windows machine which is at 11, and I have, sorry, this is my Linux machine, this is my Windows machine which is running on a virtual machine VMware, and then there is another host. So these 5 hosts are up in these 30 ranges. You can also search for a sub range for a subnet. You can do it like this, 1/24. So it will mask the last 24 bits, and it will search inside these bits. So let's start with 16 bits. So now this will mask out the last 16 bits, and then it will search in this subnet. As you can see, we are starting to get answers for different hosts. So I'm going to stop my execution here. So this is you get 0.1, and then 0.10, 0.11, and then 0.30. So it scanned 4 hosts, and then I cancelled the execution. So this is how you can search for different hosts in your own network, and you can get their MAC addresses, etc., and different information, which port, for example, which port is open, and then you can use this information for creating your attack vector. Okay, so this is a command line interface for Nmap. Nmap also has a very efficient, what is called a graphical interface. So I'm going to, and it's included in Kali Linux by default. It's called ZenMap. So you can write your commands here, which I wrote in previous terminal, or you can select different options from here and try to work around with them. For example, if I want to ping 92.168.0.24, so I'm going to search this subnet with 24 bits, and then I'm going to use a very quick scan because I don't want to waste a lot of time. You can also use lot of different type of scans, for example, regular scan, quick scan, ping scan, intense scan, but I'm just going to use a quick scan so I get my results quickly. So now the Nmap has started, and it will start searching for host. Okay, now the whole scanning process is done, and you can see that 255 IP addresses were searched and 5 hosts were found active. And these are the hosts that are found active. So 01, 010, 011, 013, and 030. So now you can get different information about them. You can see that this graphical interface provides a much more useful and easily understandable information, and then you can build on top of this information to attack the victim machine. You can also search for a range of ports. For example, if you don't want to scan for all the ports, you can just scan certain ports. For example, you have to give the arguments -p and then the number of ports. For example, I only want to search for first 100 ports, so I'm going to write it as like this, and then I'm going to search for this IP. As you can see that it cited first 100 ports, and it found out that only 25 port number 25, which is SMTP or email port, is open, and you can use this port for attacking the victim machines. This is how you can define a range of ports that you want to scan. You can also write, if you want to scan all the ports on a machine, you can just write -p- and it will scan all the ports. And you can see that it gives us 3 ports that are open: 25, 902, and then 8999. You can also search for operating system on the running machine. For example, if you want to search which is the operating system on this machine, you can just write -a and then the IP address of the host, and if you press enter, Nmap performs certain tests to identify which type of operating system it is. It may or may not return the correct results, but if it's returned, it's most probably that the operating system is the same that is returned by Nmap. So it's taking a lot of time, but this is how you can use it. It's performing certain tests to determine which operating system it is. So it's taking a lot of time. I'm not going to let this run forever, but this is essentially how you can run it. You can read the documentation about Nmap here. Where is it? This is OS detection. As you can see that this is -O with enable OS detection, and you can give different arguments to it, search for different type of operating system. So that's it for Nmap. See you in next lecture. Welcome back everyone. In this lecture we are going to use Nmap to create a network scanner. This network scanner will help us to find host on our local network. So what we basically want to do in this lecture is to use Nmap or specifically an Nmap wrapper that will help us create scripts that can be used later to identify different networks based on our IP address. So let's start with it. So the first thing we need is an Nmap library. So if you go to github.com or just search Nmap Golang, you will see a link called Nmap. So this is an Nmap mapper or a mapper provided for Nmap in Golang. So this is basically deployed in Golang. So what you can do is that you can use this mapper to create your own script based on Nmap. So in this lecture we will do this process. We will use this library and then use this library to create our own script which identifies different devices over our network. So the first thing is to install this package on our local PC. To do this, just simply copy the link of this, which starts from here. That is github.com/ullakut or whatever the name is, and then /nmap, and then go to the terminal and write go get and then paste the link. So what this command will do is that it will install this library on your own on your local PC, and then you can use this library to create your own scripts. So let's start and then click. I have already installed this library, so there is nothing that appears here, but you will have different progress going on and it will show that this package is being installed. Once this package is installed, this package is available to your local Go system and it can be used to create scripts. So let's start creating scripts. So the first thing we need is that we need to define our target IP address for which you want to search for devices. So in this case I'm going to find devices over my local network, so I'm going to define my target as my local network. So I'm going to create a new variable called target IP, and then I'm going to define the IP address. So it would be 192.168.0.1/24. So I'm going to define a whole subnet which I'm going to search for IP addresses. Okay, once we have that, we can use the library that we just downloaded to create a scanner that will help us scan the devices on our network. So let's create a new scanner. So to do this, you have to write nmap.new scanner, and you can see that there is an automatic import here which is called github.com/ullakut/nmap. So now we can use this method to create an Nmap scanner which can then be used to identify devices. So once you have that, you can have to see which arguments it requires. So the first argument that it requires is a target IP, but according to this library standards, there is like a certain way for which you should give the inputs. You can't directly write, for example, target IP and then expect the correct results. So you have to wrap everything in Nmap. So to do this, you have to write nmap.with targets, and then you have to write the target IP here. So this is the first element that you have to define. So first, when you have initialized the targets, the next step is to find out which ports you want to search. So similarly, nmap dot with ports, and then you have to define ports. I'm going to use the very commonly used ports, which are HTTP and HTTPS. So the port numbers for these ports are 80 and I think 443. So now we have two ports. Now we have our target and then the ports that we want to scan. Once we have that, we need to define a timeout so that our program doesn't run indefinitely. So in order to define a timeout, go ahead, according to this library standards, you have to define a certain context for timeout. So to do this, you have to define nmap.withContext. Okay, this context requires a context element. If you open the documentation, you can see that it requires context.context. So first we have to create an object of type context, and then you can input this object here. So let's go over here and define the context. I'm going to call it CTX. Once you have that CTX, you can call it context dot with timeout, since we want to set a timeout for our program. Once we have that, you can open this documentation and you can further see that it requires two elements. First is the parent context and the second is timeout. So first define timeouts. Let's say we want to have a timeout for 1 minute. So I'm going to call it 1 cross time dot minute. So now we have a timer defined. Now we should also define the first element, which is let's go here, which is the parent context. So in according to this library, the context for parent is context.background. So now we have this the two elements, which is context.background and the timeout for which you want to run. So there is an error. If I hover over it, it says assignment mismatch. So it returns an error to if there is no proper context. So I'm going to call it, it's not an error actually, it's called a cancel object. And if you hover over there, you can see that it returns a context and then it returns a cancel function. Cancel function is used for cancelling the operations if timeout occurs. So you have to write defer and then cancel. So what this process does is when timeout occurs, it runs this function and then it handles all the executions properly. Now once we have this object CTX, we can give the CTX object here, and now everything looks complete. Now this scanner should be stored in some object. I'm going to call it scanner, and then it also returns an error. So firstly handle error. If error is not equal to nil, log.fitter error. Okay, once we have handled the error, our next step is to use this scanner. So to use this scanner, simply you can call scanner.run to run this scanner, and this scanner returns three elements. The first one is the result of scan, the second one is the warnings, and the third one is the error. So I can use error handling here. The next step is warning. I can do the same for warning. I just have to replace error with warning here. Warning. I'm going to use %s here, and I'm going to use fatal F here, \n. Okay, now we have handled warnings and errors properly. The next step is to use these results to find out what our host or devices are. So if you hover over it, it doesn't return properly, but if you click over here, you can see that it returns 3 elements. The first one is result, which is of type run, and then the warnings, and then the error. Now we have to use this result function. It's a type of struct, so, and it has a list of hosts. So this is the element that we are interested in. So the result contains, where is it, a host object or list of hosts, and we are interested in this host. So what we want to do is that we want to loop over this results dot host. So I can start a for loop for host equals to range results dot host. So now we have a list of hosts, and we can select host to iterate over each host. So the first check we should perform here is to check if the number of hosts are greater than 0 or not, and if they are not, we can simply continue the loop or skip the loop. So let's put a check here. If length of host dot ports equals to 0, or or length of host dot addresses equals to 0, we can just continue the loop. We don't want to see anything. If the case is not this, then we can simply print out the host addresses and their corresponding ports. So I'm going to use a print statement here. Println. Instead of println, I'm going to use printf, and then I'm going to print s or q in this case, and then IP and whatever host dot address. So the IP address is stored in the first element, and the MAC address is stored in the second element. But in some cases we don't have in every case we won't have this MAC address, so we have to put a check here. For example, if length of host dot addresses is more than 1, then we can also print out the MAC address. Printf %s MAC host dot addresses and 1. So this is how you can print out the host and addresses. Let's run this and see what happens. Go run p1. Okay, first let's open this in terminal, and then go run p1. As you can see that now it's scanning. Once it completes scanning, wait, I'm going to put a new line character here so it's more readable. Let's run it again. Okay, now you can see that we have different hosts and the associated MAC addresses here. So this is how you can get and scan your network and find out the corresponding IP addresses and their MAC addresses respectively. So that's it for this lecture. So the next step is to see since we are working with host, if you write host dot and then ports,
you can see that it returns a list of ports. So we can loop over these list of ports and print out each ports individually for each host. So I'm just going to write here. So let's start with creating another for loop for port, and then looping by range, and then looping over host dot ports. So now we can use this list of ports to see which ports are opened or not. So I'm just going to write a print statement, port. I'm going to write \tab here just to make it more readable, and then we have to see which ports are we working with. So %s, and then I can write port.id. So this tells us which port number it is. We can also see which protocol it's working on. So if you want to check out the protocol, you can write %s here, and then you can write port.protocol. Similarly, you can find out the state of the port, for example, if the port is open or not. So I'm going to write %s, and here port.state. The next step is to find what's the service name the port is running on. So I'm going to write %s, and then here port.service, service.name. So now we can see which port service it is running on, for example SMTP, FFT, whatever it is. So let's clear it and run it again. Now it's searching for the devices. Once it has identified devices, okay, let's wait here. %n. Clear. I'm going to run it again. Okay, now you can see we have a router which is 192.168.0.1. It has an associated MAC address which is this one, and then it has ports number. Okay. Oh, so its port.id is this integer, so I'm going to write is %d here. Clear. Okay, now you can see that we have a port number 80, and the protocol it's running on is TCP. The port is opened, and then the service running is HTTP. Since we are only scanning 2 ports, which is given here, where is it here? So just these 2 ports are shown. If we have multiple ports, for example, if we scan another port, let's say 999, you can run it again, and you can see now it will give information about the other port. So it's port 999, TCP closed, and then the service name. So this is how you can search for ports as well. So that's it for this lecture. See you in next one.